Section 9.5 talks about the famous cross product given two vectors a1, u and v. So u is a1i plus b1j plus c1k. V is a2i plus b2j plus c2k. The cross product is given by that formula. Of course, you're not expected to memorize that. So this is how we find u cross v. I'll take vector u cross v. So what I do, I list u first. So it's always I, j, k. I list u, and it has to be in that order. It does matter which order you list those in. And I list b. I list v. So the order that those come in, you have to list them in that order. You can't switch. And what I do, I find the determinant of this. And that's how it works. Well, how does the determinant work? If you recall, we're going to take the I component times, and let's see how we're going to do this. We're going to do this kind of quick. Let me show you. And when we write those, isn't that the product of those minus the product of those? Right? I could write that out. I could say that's I times b1c1 b2c2, and then do this afterwards. That's going to be a lot of work, and we're going to do this on almost every problem. So we really want to find a quick way of doing that, and there it is. Let me show you how we find the j. This is always negative if you remember. So I take the j, and if I cross j's row and column, isn't that a1, c1, a2, c2? Can't I just do this right here and save myself writing all of this minus a2, c1? Negative j, there it is. That's the j component. And now I go back. And if I want the k component, wouldn't you say that's k times cross k's row and column? You're left with a1, b1, a2, b2, and then find that, or simply say, well, the k component will be the product of those, a1, b2 minus a2, b1. So, how does that work? Well, guess what? Look at what we got. And look at what they have. And do you see we literally got what they have? Now, I'm not going to say you either memorize this or you derive it. You derive it every time. Every time you find a cross product, I need to see how you got that. So let's practice that. Let's make sure we're getting that. And let's get a few things out of the way just to make sure. I know you're probably wondering, what's the cross product? Don't worry, everything's coming your way. Just give it time. Don't be hasty. So two things I need to do here first. First, I need to find u cross v. There's u, there's v. U cross v would be the determinant I, j, k of what? 1, 2, 3, negative 2, 1, negative 3. That would be what? And let's see how this works. The I component, negative 6 minus 3. We always put a negative in front of the j component. Negative 3 minus a negative 6 is plus 6. And the k component, one minus a negative is a plus 4. So I'm getting this vector to be a negative 9, negative 3, and a 5. I was given two vectors, and I just found the cross product of those. What if I wanted to find V cross U? Same thing, not in vector land, not true. So if I take V first, negative 2, 1, negative 3, and 1, 2, 3 for U second, how does this work? And let's see. The I component, 3 minus a negative 6 is plus 6. Got it. The J component, negative 6 plus 3. The K component, negative 4 minus 1. And do you notice how those are related? It turns out that this is 9, positive 3, and a negative 5. So, what did we conclude out of this? We conclude here that U cross V is negative V cross U. So it's a big deal for you not to mix those. I'm going to shift this a bit to the left so I could fit all of those in. There we go. And I'm going to fit this a bit to the left and this a bit to the left, because the next step is really simple. Now it says find U cross, U dot it with U cross V. What the heck does that mean? Well, U is 1, 2, 3. U cross V is negative 9, negative 3, and 5. What would that be? Isn't that negative 9 minus 6 plus 15? That's a 0. And it also asks for V dotted with U cross V. Well, what's V? V is actually negative 2, 1, negative 3, negative 3, dotted with the cross, and the cross we got it to be a negative 9, negative 3, and 5. What would that be? That would be an 18 minus 3 minus 15. That's a 0. What does it mean when you dot two vectors and you get a 0? That tells you that, given two vectors, if I found the cross product, then the cross product is perpendicular to both of those two vectors. So if I'm given two vectors and I want to find the cross product, which is a vector, is perpendicular to both of those vectors. Properties / formulas of the cross product. Given two vectors V and W, and theta is an angle between 0 and 180 degrees, or pi radians. Couple of things to know. If you take vector W and you take vector V. Okay, let me do it backwards. If I take vector V right there and vector W right there. Okay, first things first. If you're looking for the direction of V cross W can be found by line up your right hand with vector V. So put your hand lined up with vector V and curl your fingers toward W. Remember, the angle has to be less than 180, so you can't go the other way around. So you're lining up your right hand with this, and you're curling your fingers in that direction. Theta's right there. The direction of the thumb would be that's perpendicular to both. This would be V cross W. and W cross V will be pointing downwards. That's the direction. Curl your fingers toward W. V cross W will point in the direction of your thumb. Second case, or second property to know, very important, the magnitude of the cross product. The magnitude. If you take the magnitude of V cross W, which is a scalar, that turns out to be the area of this parallelogram. That turns out to equal the area of the parallelogram that the two vectors enclose. Which means, if I want to find the area of the triangle that the two vectors enclose, I'll take area of the triangle that the two triangles enclose, I'll take half of the cross product. And lastly, the magnitude of V cross W is the magnitude of W times the sine of theta. The dot product use the cosine, the cross product use the sine. Two vectors are parallel if and only if the cross product is 0. Well, think about it. If I get a 0, doesn't that mean that the sine of theta equals 0? Isn't the sine of theta equals 0 either right there, which means the angle is 0 degrees or the angle is pi? And that means the two vectors either line up, the parallel, or their opposite direction that's parallel as well. So now that we know this, let's get a few things out of the way. Given those two vectors, find a unit vector that is orthogonal to both vectors u and v. Given two vectors, find a unit vector. A unit vector is a vector with length of 1, we know that. That's orthogonal to both of these vectors. Well, let's see. If I find the cross product, either way, this or negative that, it doesn't matter. IJK of 2, negative 3, 1, 3, 2, 1. That would be what? That would be, now I like lining them up under, the I component is negative 3 minus 2. Oops. Negative, always negative. The J component, 2 minus 3. And the K component, 4 plus 9. This vector right here that I just found, maybe I should have put it there. There it is. It's easier to put it under because it lines up nicer. So this is negative 5, a 1 if I'm not mistaken, yeah, and a 13. This vector right here is perpendicular to both u and v. Note, u cross v is orthogonal to both vector u and vector v. There it is. That part we found. There's another thing. We want it to be a unit vector. How do you find a unit vector? Now I'm going to take the magnitude of the cross product. So, magnitude of the cross product. We know how to find the magnitude of a vector. That is negative 5 squared, which is 25, plus 1 squared, which is 1, plus 13 squared, 169. So the magnitude of u cross v turns out to be the 170, is that 195? And my unit vector would be u cross v divided by the magnitude of that vector. I know it looks messy. So 1 over the square root of 195 times negative 5, 1, and 13 will do. Alright, how about example 3? Use the given information. We're almost done. Let me see. Yeah. So I'm going to continue on with this. It's going to be probably about 20 minutes or so. Use the given information to find magnitude of U cross V. How do I find the magnitude of U cross V? Well, they gave me U and V. I'll find U cross V first. That would be, list U first, 1, 1, 2, V next, 1, 0J, 1K. And what would that be? That would be the I component, 1 minus 0, that's 1. The J component, 1 minus 2. And the K component, 1 minus 1. Oh, 0 minus 1, I'm sorry. So if I make an error in my calculation, just follow the idea. 1, 1, negative 1. You see the K component is 0. Yep, that's right. And now what? Now if I want to find the magnitude of U cross V, I know how to do that. That's the magnitude of a vector. That I've been doing all along. That is the square root of 1 squared plus 1 squared plus 1 squared. That's radical 3. There it is. So we did that over and over. What if they gave me this? Well, I have a formula. And again, if there's a need for that, hopefully I will provide. But I know that the magnitude of U cross V is the magnitude of U, magnitude of V, the sine of theta. Well, that would be the magnitude of V is a 3 for the sine of 45 degrees. Look at that, without a calculator. 12 times radical 2 over 2, that is 6 radical 2. Got it. How do you like that? Let me just make that the way I want it written when you do this on your homework and your test. There it is. And last problem. This is something that comes up. Everything that you see here comes up in third semester calculus. Not first, not second. So they're going to mention this. Hopefully you'll be reviewing. Find the area bounded by the triangles. It's very hard to do. This is 3D stuff. You're not required to graph it, of course. But 1, 2, 1, 2, 3, that's point A. Negative 2, 1, 2, 3, negative 1, that's point B. And negative 2, 1, 1, 2, 3, 4, that's point C. We're trying to find the area of this triangle. So how are we going to do that? Well, this is what we're going to do. We're going to find vector AC. We're going to find vector AB. And we're going to cross the two. And the magnitude of the two will get me the area of the parallelogram that those enclose. So I'll take half of it, and that will be the area of that triangle. So area here would be, AC would be, let's see how that works. And okay, it doesn't matter which order you do those in, but normally we go AB, AC, right? Just saying. So AB, negative 2 minus 1 is negative 3. 3 minus 2 is a 1. Negative 1 minus 3 is a negative 4. AC, negative 2 minus 1 is a negative 3. 1 minus 2 is a negative 1. And 4 minus 3 is a 1. And if I take AB and cross that with AC, That's the quickest way of doing this. The I component, 1 plus 4. The j component, negative 3 minus 12. And the k component, 3 plus 3. So this is actually a 5, a 4, and a 6. Now, to keep in mind how this works, if I take the magnitude of 5, 4, 6, square root of 25 plus 16 plus 36, that is the square root. What is that? 6, 12, 17, 57, if I'm not mistaken, whatever that is. That's going to be the area of this whole parallelogram. So, the area of triangle ABC is going to equal half the square root of 57. So in 3D, dot product and cross product dominate over a lot of applications, and this is all you need to know about it. That concludes this section.